Welcome back to Chemistry 2, Unit 4 on Chemical Kinetics. This is Lesson 3, the Integrated Rate Equations and Half-Life, video number 5. So in this video, we're going to look at our last order integrated rate equation and half-life, and that is for zero order reactions. So in this case, the rate is not dependent on any concentration of substance. It's just dependent on K. If we look at the units here, ms to the minus 1. So our integrated rate equation is A sub 0 is equal to, it's just A is equal to A sub 0 minus KT. Our half-life, T1 half, is equal to A sub 0 over 2K. I'm not going to go over the derivation. So on all of these, and I'm going to switch over to a paper that you have in your packet that looks like this. We can look at the orders of our reactions. So first, second, and zeroth. Our rate laws associated with that, our integrated rate equations, and our half-life. So I just copied all of this data down so I have it on one sheet. And you will have this exact same thing on the test. The one thing that you need to know is the units of K. And if you've noticed, the units of K actually tell us what type of reaction we have. So if we have time to the minus first, it's a first order reaction. If we have m to the minus 1 time to the minus 1, it's second order. And if we have m time negative 1, it's a zero order reaction. Those you should know. So on a problem, if you're not given that this is a first order reaction, but you're given K to be negative time to the negative 1, you know that it's first order and you would apply the correct law. So you should copy this down into your notes. So moving back to our two equations here. We know that this is zero order. We know that we're given a K value. How much time will it take for 0.525 molar HI? So here is our original concentration to be reduced to this amount. So here is our A. So how much time? There's our variable. So all we have to do is put our numbers in. A is 0.0500 molar is equal to 0.525 molar minus K, which is 0.0800 ms negative 1 times T. So I have to get T by itself. So if I have this 0.525 molar, I'm going to subtract that from both sides. So when I subtract that, I get 0.0475 is equal to negative 0.0800 T. And then I can divide both sides by negative 0.0800 to get T by itself, and I get T to be 5.94 seconds. So we just use our awesome algebra skills to solve for this. Our second example is using the half-life equation. So in this case, this should be if, not is. What is the half-life of HI if HI's initial concentration is 0.750 molar? So our half-life equation, which we gave up here, is equal to A sub 0. 0.750 is the original concentration over 2 times our K value, 0.0800 ms minus 1. So our m's cross out, we're left with s to the negative 1, which means that when we divide these two, the s comes up on top, and we get our half-life to be 4.69 seconds. There is our answer. You are now all set to work on both integrated rate equation worksheets at this time.